With clean architecture, the domain and application layer are at the center of the design, and this is known as the core. Now, within domain, we have enterprise-wide logic and types, and within application, we have business logic and types. And so, what's the difference? Well, the enterprise-wide logic could be used across many systems, whereas the business logic would be specific to this system. Now, rather than have core be dependent on infrastructure concerns such as data access, we invert those dependencies. So infrastructure and presentation all depend on core. And this is achieved by adding abstractions inside of core, which is implemented by the layers outside of core. So for example, if we wanted to implement a repository pattern, then within core, within the application layer, we would add an interface for iRepository, and within infrastructure, we would add an implementation for that interface. So, for example, a concrete repository for EF core. Now, you can see that presentation and infrastructure are dependent on core, but they're not dependent on one another. So, for example, there's no arrow flowing from presentation for infrastructure. It's pretty common to see this out in the wild, but you want to avoid it. So for example, let's say that you have a web API controller for orders that's responsible for creating an order. When an order is created, you want to send out a quick email, so that web API project has a dependency on infrastructure so that it can send out that email. So we're saying don't do that, because what that results in is placing logic inside of presentation, which is then not independent of the infrastructure. That create order and the associated notification should go inside of core, where it's independent of those external concerns, can be tested, and also if you decide to change out the UI layer at a later date for something else, such as Blazor, you don't have to rewrite that logic. It's not stuck somewhere in a web API controller. So you can see that all dependencies flow inwards, and this results in an architecture and design that is independent of frameworks, so it doesn't require the existence of some framework to operate. It's highly testable. In fact, everything within core is isolated. There's no dependencies on any kind of infrastructure, no dependencies on the outside world, and it contains all of your logic. So you can not only test this, but you can 100% unit test this. And that's really great. It's a really big win. It's independent of the UI, so in the sample application that we're looking at, I'm building an Angular spa. We can easily switch that out because all of the logic is so well isolated. We could switch that out, for example, to Blazor, which we're doing, I guess, in a couple of years now, depending on how fast it goes. It's independent of the database. The sample application uses SQL Server. We have switched it for Postgres. Cosmos DB is in the works, and that's achieved completely because we're using Entity Framework Core, and we can switch out the provider. So that's quite easy to do. Finally, it's independent of anything external. So Core simply doesn't know anything about the outside world. Now with this design, you can see there are 3 layers. Think of that as a starting point. You could actually reduce it to 1 layer. So you could have just an application and domain combined into a single core project, and that would be fine for something of lesser complexity, or you could add the layers. Just remember that we need to keep those dependencies pointing inwards to achieve the good separation of concerns. Let's have a look at a couple of examples. So the Northwind Traders sample, who here has heard of Northwind Traders? Okay, just a few people. Awesome. So Northwind Traders was built in 1992, and it was built using it was built as a sample database for Access. And I thought, well, why aren't people using it anymore? Like, we've got this great sample database, so I brought it back. So now Northwind Traders is cool again. It's built on ASP.NET Core 3 with Entity Framework Core 3. And I've even included the ASP.NET Core Identity with Identity Server 4 functionality. So it's a sample of clean architecture. And this is the sample that I've been using since I started talking about clean architecture. And something really wonderful happened with this solution. It's on GitHub and it's open source. There's now a really strong community behind it. Let's have a quick peek. So you can see this solution now has, I'll just zoom out a bit. It's got almost 3,000 stars and close to 1,000 forks, which is pretty good for a sample access database. But what's even better is all of the issues and conversation that has occurred around this. So you can see, yeah, there's 17 issues open right now, 18, and 187 closed. So we've had a lot of great issues raised, we've had a lot of questions answered, and as a result, we've had a lot of changes made to the application to be what it is today. So it's definitely worth taking a look at those issues, and then you can read through those and understand the reasoning behind some of the choices and understand some of the new features that came in. Also worth taking a look at is the existing clean architecture video. Let me just find that. So the original one that was done in 2.1 is not that one. Let me go to YouTube for this one. So if we go clean architecture SSW, there it is. There are over 320 comments on this video alone, so I've responded to each and every one, and we are handing out the evaluation forms now. So I've responded to each and every one, so there's a lot of great discussion there as well. So if you do want to learn more, you can learn a lot from watching the video. You can learn even more from reading all the issues on GitHub and reading the discussion in the YouTube channel. Back here. So we learnt a lot, and that was amazing. So using those lessons, I've now created a new template. Waiting for this to change. There we go. A clean architecture solution template. So I wanted a really great file, new project experience. Up until now, I'd been using the Northwind traders and retrofitting it, or creating it from scratch, and adding all of the projects and tools and technologies that I like to use, as well as all of my kind of infrastructure classes. So this one is a .NET Core template package, and it's the same design: ASP.NET Core 3, EF Core 3, Identity 3, Identity Server 4, and the repo is right here. So you can come over to here, and you can go use this template directly on GitHub. And that'll give you the opportunity to create a new repository based off the template straight away. Or it is a .NET Core project template, as I said, so you can actually install it using the .NET Core CLI tools. So to do that, basically run .NET new install clean architecture solution template, and then run .NET new clean architecture solution. And that's it. You'll get everything that we've kind of talked about today, and all set up and ready to go. Let's have a look at that in action. So I've created, I'll create a new folder, make directory clean architecture Sydney, cd ca Sydney. So it's an empty directory, right? So if we go .NET new install clean.architecture.solution.template. So that goes and gets the NuGet package, installs the template, and then displays a list of all the templates, which is kind of a bit over the top. But if we scroll to the top here, you can see it appears right here at the top, and that's our short name for the solution template. So if we want to create our new project, we go .NET new CA solution, and it's that easy. So now we could go just start CA Sydney.solution if we're on Windows. That'll fire up Visual Studio 2019. We can have a look at exactly what's been scaffolded. Okay, so you can see that it's separated into two folders. There's the source code, which is the primary projects, and then the tests. You can see that the directory was used to namespace the project. So the solution is called CA Sydney. And if we dig into, say, the domain CS_proj, you can see that it's namespaced with CA Sydney as well. So it's a really great starting experience. We've also got all of our test projects. So we had a look at some examples of testing today. These are the more advanced examples. So there's unit tests for the domain and application layers, including all of the logic we use for in-memory. There's also some integration tests. The integration tests are looking at some auditable entity functionality that I created for working with EF Core. So when you save changes, it automatically saves user information and date time information. So for example, I should just show you, it's much easier. So if we have a look at, say, this to-do item, you can see that it's inheriting from auditable entity, which is just a base class, which just adds 4 properties. So there's created by, created, we should flag that with UTC actually. Last modified by and last modified UTCs. So these are referring to the user IDs, and that's referring to the date and time the operation happened. So just extending an entity with auditable entity is enough for it to start tracking those changes, at least in relation to the user and when the change was made. So that's implemented within the application DB context, and save changes is overridden, and you can see here. We're just looking through the change tracker to find anything that is of type auditable entity and applying the appropriate changes to those properties. So we have some integration tests for that functionality. And then further down, we have some web UI integration tests or functional tests or subcutaneous tests, whatever you would like to call them. And these are the ones that are testing at the API level. And you can see, so in here I have a controllers folder, matching the controllers folder in the web UI project. I have a to-do items folder, which matches the name of the to-do items controller. And then I have a class for each action method. And then for each action, I have one or more tests. So you can see the delete method, it's just checking the basic inputs and outputs. It says, hey, given a valid ID, it's going to return a success status code. And then given an invalid ID, it returns not found. So those are some really nice basic tests that are going to exercise the full stack of our web application and hopefully provide a really great return on investment. You can see that they're really simple to write. They're tiny. I can get an authenticated client just by saying factory.getAuthenticated_client, and that's because that's all built into this template. You know, I've done all of the hard work so that you don't have to. So you can see the getAuthenticated_client goes ahead and creates a client using the ASP.NET Core web application factory. It gets a token using my helper method to grab a token. It sets the token and then returns the authenticated client. So you can do testing for these authenticated clients, you can do testing for the anonymous clients, you can pass it, you can use the default user, you can pass in your own user, so if you're testing specific roles and responsibilities, that's going to be easy to do. So the testing experience is great. I'm really happy with that result. So let's have a look at the different layers. So previously, and in the Northwind Traders solution, I had a separate project for infrastructure and a separate project for persistence. But there just wasn't enough going in persistence to have a separate project. So I've gone ahead and just added it as a folder to infrastructure now. And it fits in quite nicely. I like that approach better. With the work around identity, there are some shared dependencies there, and it's simple enough to make that work nicely. So you can see within infrastructure I've got some files, and that's relating to some functionality around building CSV files as a sample. There's some functionality around identity, ASP.NET Core identity. There's our application user. We've got and also an identity service, which I've started to flesh out a little bit. So the identity service just has a few methods. We can get username based on the ID. We can create a user and delete a user. Now, the implementation for this is using, just trying to get to that. What was there? We'll go back. The implementation for that's using the user manager. You can also go ahead and inject the role manager, or you could split out the identity service into 2 separate services if you wanted to. But you can see behind the scenes, we're free to implement whatever logic we want in there. And this is a really important point. You know, we're using an identity, but we've placed it in infrastructure. And as far as the logic's concerned, it's only this identity service interface that we're going to be programming against. So if we do want to move away from identity at some point in the future, well, that's fine. We just need to write a new implementation for whatever technology we've chosen to supply the methods that we're actually using, such as, you know, the get username, the create user, delete user, async, whatever it is at that stage. So nice separation of concerns there. So let me see. In infrastructure, we have persistence, We talked a little bit about data annotations and configurations today, but we didn't have a look at any configurations. Well, you can see in here an example of a very simple configuration. And of course, you can go to Northwind Traders for a more comprehensive example. So this is the configuration for the to-do item. And it's basically saying, hey, we've got this property called name. It's a max length of 200 and it's required. The important part is that it's based on entity type configuration of type to-do item. And it's that functionality that allows us to go and automatically wire it up. So you can see here, saying builder.apply configurations from assembly and just get the current assembly. So that's magical. You don't want to do it by hand, even if you've only got 2 configurations, because when you go to add the third and you forget, and then, it's just, those things are annoying and they interrupt our flow. You also notice that I've been careful to actually include base.onModel creating. In the past, that wasn't necessary. It didn't do anything. It was probably good practice to include it, but we never did. And as soon as I started using the new ASP.NET Core identity functionality, that bit me in the bum. So you do need it now. It does have some functionality in there for identity. So just keep that in mind. You can see that in the clean architecture template, we've also implemented an interface. So iApplication DB context. That interface is really important. So in core, we still have a reference to Entity Framework core, but we don't have a reference to the DB context. And that's important because it allows us to keep that dependency from persistence to application inverted, which in turn allows us to be able to do the functionality like the auditable entities. If the relationship was facing the other way, we wouldn't be able to do that. Because when we do the auditable entities functionality, I probably didn't make that super clear. Let me find that context. When we do that, we're actually injecting in some services. So we're injecting in the iCurrentUser service, and we're injecting in the datetime service, and that kind of feeds into how we can actually write those values. So the dependency is very important in that way. Let's see. So we've had a good look at infrastructure, I think.
Service, please. You have a service.
Yes, thank you. So at the moment, it's just got a datetime service in there. So it's not very exciting. I'm going to change that to be, I want it to be, there we go. Now UTC, and we want it to be UTC now. So that'll be a nice implementation, right?
If you want to consume all the APIs, for example, the service,
Yeah.
so it'll be inside of the service.
Yeah, exactly. Yeah, put it inside of services. Hopefully that API is generated a client for you, so you can just download it as a NuGet package, or if you do have to write it yourself, you can put it into services. But so the implementation there. Sorry, I should repeat that question so everyone can hear. So if you do have to access an external web API, where does that go? So the implementation will go in services, and the interface will go in application common interfaces. And so the application layer will program against the interface, and the implementation will be wired up via dependency injection. So the reliance on Entity Framework core inside of the application layer is there, and that's right. So you can see here we've got a dependency just on Microsoft.Entity Framework core. So we don't have a dependency on a provider. So it's not dependent on some kind of database. It is dependent on EF core, which is a framework. So that's definitely a trade-off. But I like to think of it this way. Entity Framework core is one big abstraction. Now, sure, if I want to avoid the dependency on Entity Framework core, I can go ahead and implement a new abstraction on top of Entity Framework core, at which point I would be independent of the EF core framework. But I don't see too much value in that. Now, if I want to achieve some other goal by implementing, say, a repository pattern, creating a repository at an aggregate root, for example, so creating a repository for order, but not order details, that would be a really great reason to implement that abstraction. And if I wasn't using Entity Framework core, if I was using, say, the MongoDB C# driver, then I would definitely implement an abstraction then. So yeah, it's a trade-off. It's about how you want to program against EF core, and whether you really require that abstraction from the ORM, which is going to change in the future. And that'll mean that we'll likely have to change code in our application layer, but we're okay with that because you know, we don't have the pain of managing the abstraction. We just have the pain of keeping up to date with Entity Framework Core in the same way that we will keep up to date with .NET Core. Okay, so I won't spend too much time looking at the domain. You can learn more about that in the Clean Architecture video. But we've got entities, exceptions, interfaces, and value objects. And inside of common, we have our auditable entity and our value object base classes. Application is worth spending some time on. So you can see that I've started adding these common folders. Normally I'd call it infrastructure, but because I have an infrastructure project, I kind of found that term to be a little bit conflicting. So common's working pretty well for me. So in the application layer, what I try to have is a common folder and then feature folders. So you can see in this sample, we have to-do items and weather forecasts, and then our common folder. Our common folder is for our cross-cutting concerns. So we have behaviors, exceptions, interfaces, mappings, and models. In behaviors is all about mediator, so I better spend a little bit of time just introducing mediator a bit more. So, oops. Mediator was introduced by Brendan, but we didn't really look at commands and queries too much, did we?
I mentioned commands and queries, but I didn't really cover how mediator calls them.
I'm going to keep it simple. I've got a weather forecast query here, and it implements mediator's iRequest interface, and it states that it will return an IEnumerable of type weather forecast, right? And then we have this handler, and it's and this is a nested class, so that might look confusing at first. I'll tell you why. We've got an iRequest handler, and it's it handles requests of type get weather forecast query, and it returns a response of IEnumerable weather forecast. So we have a query, which is our DTO for making the query. This query doesn't have any properties, but normally we would. Maybe we would have some pagination or some filtering for the type of query. Maybe we would just have an ID if we were getting a specific record. And then we have the handler, and the handler is responsible for executing the query. So in this case, it has in all cases for an iRequest handler, it has a handle method, and it returns some result. So the result here is a collection of 5 random weather forecasts. Now what we're seeing here is that with mediator, every query and command is a request with an associated request handler. And because everything that's coming into our system is now a request, we can have a request pipeline, okay? And we can use that request pipeline for cross-cutting concerns. For example, we have in common behaviors a request logger, and this request logger takes a dependency on iLogger, the current user service, and the identity service to log the name of every single request that comes through the system. Not only does it log the name, it logs the user ID and the username and the DTO of the request. So if this request did include an ID or some filtering or some pagination type properties, that would actually be logged into our structured logging. So when we were looking at Seek before, we could then start to filter by user ID. And we could say, show me all of the requests that this user made on the 1st of November between 11 a.m. and 12 p.m. And because that user's on the phone to us complaining about an issue, we can get a really good picture of what was happening. And if we see that they made a request, let's say to create an order, and that failed, we can copy the JSON of that request, add it to a test, and hopefully just have a failing test because we have the DTO that was used to make the request. Now, obviously, we have to be careful with security and trimming out sensitive values, but we get a lot of power there, and this is 32 lines of code for every request that comes through our system. So some other behaviors that we have is a request performance behavior. There are probably better ways to do this, but I like this approach. It's simple. It's a pipeline behavior for mediator. So it runs before and or after each request. So the implementation is we start a timer from system.diagnostics. We wait for the result. So we've got the request, we wait for the result, the response from that request, we stop the timer, and if the elapsed milliseconds is greater than 500, then we just log a warning. Same sort of information. And maybe when we have a little bit of time, or if someone complains about performance issues, we can go and look at which ones are taking the longest milliseconds to run, because we have that in the log, and we can filter by that, and yeah, go from there. One other thing that I have, which was really important because we've moved validation from the web UI layer into the application layer. And we saw earlier today, we had a really nice validation experience. I wanted that same validation experience. I wanted all requests to be validated automatically when they come in. And that's what the request validation behavior does. So it's just, it basically looks at the request and it gets the validation context for that request. It sees if there are any validators associated with that request, it will call v.validate on it. It will select all of the errors from all of those validators. And if there are any errors, it goes ahead and throws a validation exception.
So that validates your comments and queries?
Yes.
From the controller?
Yeah.
It validates it within the application layer, independent of anything outside of that. So independent of the presentation layer and independent of infrastructure. So it then throws a validation exception. So the next piece to that is how do we handle that at the web layer? So that's really easy. We've got a nice little bit of middleware, custom exception handler middleware in the UI project that's basically wired up to catch validation exceptions. Return the status code as a bad request 400. You can change that to be whatever you want. Some people like to do unprocessable entity because it makes more sense to them. And then it returns the result, the failures. So this is something that I would actually like to update. Newer responses are coming back as problem details, so I'll update this to come back as problem details as well. So how do we set up the mediator behind the scenes? So we've just got a little API controller based class, and its responsibility is just to dependency inject mediator when required. So it exposes this property. It'll go ahead and get mediator when it's needed. The other part to the puzzle.
Yeah, who can guess which file sets up mediator into dependency injection?
You'd be close. So within
startup.cs,
we have add infrastructure. Okay, so
oh yeah, you've changed it.
one of the things that I do with this project is I create my own service collection extensions, so that when I want to wire up all of my application related dependencies, or when I want to wire up all of my infrastructure related dependencies, I can just call that extension method, which hides all of this. All of the wiring up that's required to wire up infrastructure. Okay, and that's really cool because we can just say, okay, it's an extension method for a service collection, pass in the configuration, pass in the web host environment, and then we can wire up our dependencies like normal. So here's your add DB context for infrastructure. There's the connection string, we're getting it from configuration still. So it just basically takes all of that code out of startup and reduces it to this, which is a lot nicer to read, a lot nicer to understand.
Let's take a look at the application then, because that's where mediator is.
Yeah, okay. Oh, of course, thank you. I was trying to work out where I should go next. So here we go. So we have add mediator, nice and simple. So we know that all of our commands and queries are requests with associated request handlers, and that's what that does. It wires them all up so that mediators knows where to send queries and requests. I think that's enough about mediator. We've got some shared exceptions. We've got our interfaces, which we saw before. My next favorite thing is the way that we're doing our mappings and projections. Let's see what I have. I'm going to go to a more complicated example, just because I wanted to show a nested projection. It's pretty important. So this is the next iteration of the clean architecture template that I'm loading now. I've added more features and I've added some more examples. So if we go into to-do lists, queries, get to-dos, let's see what we have here. So we're returning a to-dos VM, and because this VM has the to-do list DTO. Here we go. So the to-do list DTO implements this class, which is a class I've created. It says I map from the entity to-do list. And what it does is it wires up all of these fields and this collection. Now this to-do item DTO also has an IMAP from. It says IMAP from to-do item. So let's look at this IMAP from class. It's really interesting. So this is a C#8 class with a default implementation. And what this is doing is it's actually saying, using AutoMapper, create a map from the source type, which is this generic type, to the derived type, which we can access by going get type. So it creates a default automapper map based on conventions. So as long as these properties can be mapped by a convention, that's all we need. Now let me go back a little bit. So then there's a little bit of magic that happens to wire that up. So we have this mapping profile class, and basically we've got a nice little method that says apply mappings from assembly, and we pass in the current assembly, and we have some code to wire that up automatically. So essentially it gets any DTOs or any view models that are implementing IMAP from of the generic type. And then it loops through all of those, it creates an instance of the type and says, okay, if there's a method called mapping, that means we've overridden the default implementation on the interface, then get that. If not, then get the default implementation that we provided on the interface and then invoke it. So this is wiring up all of our mappings for free with AutoMapper so that we don't have to touch it. All we have to do is implement IMAP from on those classes. And then if it's not a conventions-based mapping, then we just we create our own implementation of mapping like that. And what that means is that you can do nested projections, complicated projections where before you had a lot of includes and then includes, you can reduce it down to just a series of maps and a single line of code. So let me show you that single line of code. That's it.
So does AutoMapper's project 2 actually wire in the includes it needs?
Yes, because
That's
it's
cool.
one big projection, right?
Wow.
And we know that when we're projecting to collections and all that sort of stuff, it's going to bring it back.
I didn't even know it did that.
Yeah,
That's awesome.
it's amazing.
Yeah.
Is this available already?
Yeah.
Yeah, no, that's right. Yeah, no. So when you typed, when you install the template, yeah, this is
what you get,
This
yeah.
is what you get. The nested projections is available already. I just don't have a sample right now, but I'll commit these changes soon. I just have to fix a couple of bugs. So let's see. So we've looked at mappings. We've got some shared models, which is not very interesting. We've looked at some features. We've looked at the dependency injection. All of the stuff that we saw with Open API today is in this solution, already wired up. All the tests. Yeah. Anything else? Oh, there's the ASP.NET Core Identity with the Identity Server implementation for an Angular app. You could quickly switch that out for a React app. That's one of the options that I'm considering, whether I should create this project just at the Web API level and then let people use it either for a microservice or for an Angular, React, or Vue app. Whether I should create different versions to support Angular, React, and Vue. I'm not sure yet. I'm kind of leaning towards leaving it at the API level and then maybe writing a series of blog posts showing you how to add Vue, Angular, and React. So feel free to give me some feedback on that. You know, one of the things that made Northwind Traders great was the issues and the pull requests and all of the contributions from every other avenue was great. So I'm hoping to see some of the same for the clean architecture template. I think that's everything. Is there anything else that I needed to touch on there, Brendan?
No, I think it's time to
Wonderful. Let's wrap it
let
up.
these people go home. Yeah.
So key points, clean architecture provides the simplest approach to enterprise application development. Our application consists of our business logic and types. Infrastructure contains all external concerns. Recall that our domain contains our enterprise-wide logic and types. Presentation and infrastructure depend only on application. I think that I made the point clear that that's important. No layers depend on infrastructure. That can be a little bit confusing at first, but remember, everything happens there via dependency injection. So infrastructure is just providing the implementations. We write up via dependency injection, and application just programs against those interfaces. So nice and simple. So generate new solutions with .NET New Clean Architecture Solution if you like that. If you don't like that, tell me why you don't like it, and let me see if I can make some changes so that it's more suitable for you. Or if you just like it a little bit and you kind of want to create your own version, then please fork it. And yeah, if you do something interesting, I'd love to hear about it.